Hello, this is the third video in the third vector series of OCR AS Core Pure Further Mathematics. We will be using the vector product to find perpendicular vectors. An important result for the vector product is that it generates a vector n that is perpendicular to, or normal to, the plane in which the two original vectors A and B lie. So when we calculate the vector product of A and B, for example 1, minus 1, 3 and 2, minus 1, 2, we generate n, or a vector that is perpendicular to both. So using the formula, this would be minus 2 minus minus 3, 6 minus 2, and minus 1 minus minus 2. You can see this example, we've got to be really careful with our signs. The vector or cross product is 1, 4, 1. If we wanted to check that it was perpendicular to both of our original vectors, we could of course use the scalar product and expect the scalar product to be 0. You may wish to pause the video now and check this for yourselves. This result can also be used to find a vector that is perpendicular to each of two lines. Here is an example where we are asked to find a vector that is perpendicular to L1 and L2, where L1 is given by the vector equation R equals 2i plus 4j plus 3k plus lambda I minus 4k, and L2 is given by the vector equation R equals minus I plus 2j plus k plus mu I plus 2j minus k. Just as when we were finding an angle between the two lines, but it was the direction vectors of the lines that we would be looking to find the angle between, in the same way, when we're looking to find a vector perpendicular to the two lines, we're actually looking to find a vector that is perpendicular to the two direction vectors of the two lines. And that is the key aspect. Remembering that the first 2i plus 4j plus 3k and minus I plus 2j plus k are just the points on those lines that we've used to sort of jump from the origin onto the line. So the direction vectors are 1, 0 and minus 4, and we're looking then for that cross product with 1, 2 and minus 1, the direction vector of the second line. And this gives us 0, minus minus 8, minus 4, minus minus 1, and 2 minus 0 using the formula, or you could be checking this on your calculators as I'm doing this, giving us 8 minus 3, 2 as a vector which is perpendicular to both lines. Now if we'd put the vectors the other way around, say for example 1, 2 minus 1 crossed 1, 0 minus 4, then we would expect to have minus 8, 3 and minus 2 as our result. As we did in the last video, we realised that A cross B equals minus B cross A. But actually these two are of course parallel vectors, they're just multiples of each other, but the multiple in this case is minus 1. You may wish to just stop there and check these results for yourselves, either manually using either the formula or the determinant method, or again using your calculator. In this diagram here, you've got to try and visualize it in 3 dimensions. And then the cross product either A cross B or B cross A, depending on the direction, is perpendicular to both A and B. This is the last video of the third vector series.